In this baselining exercise, I'm going to record a waveform for the ignition coil, and specifically for the primary side of the ignition coil. So this diagram shows how the ignition coils are powered and controlled. So the first thing to note is that the green wire that connects to the top of the ignition coil is basically always on, provided that you have a key in the key slot and that you've at least pressed the start-stop button, whether you've got your foot on the clutch or otherwise, so that it goes into that ignition phase 2. And what happens then is the car access system, the CAS, which you see up on the left-hand side, activates this relay that you see. And provided the fuse is good for the engine electronics, the power is provided through the relay onto the green wire and then onto the ignition coil. On the other side of the ignition coil, we have a controlled ground. So the way the ignition coil is controlled is by switching the ground on and off. It actually switches, I think, between a number of voltages, but basically the whole thing is controlled by switching the ground wire. So on cylinder number 1, you can see that the wire we're expecting to see is black with a white stripe. In fact, on my car, it's not. And we'll see when I show you where I probe these various connections, you'll see the colours of the wires there. The diagram I've got says I should be looking for black wires with coloured traces through them. What I've got is white wires. So my circuit diagram is different. And then the ground lead for the scope I've connected to the signal ground, which is the brown lead, into this module 5. Right, so we see the signal lead coming in at the bottom of my scope here. The thing to note is that I'm using an attenuator. So even though the primary side is nominally switching 12 volts, when the circuit opens and the magnetic field around the coil collapses, you'll get a really high voltage induced into the primary side, which will probably be around 300 volts, something like that. So you need to make sure you use an attenuator, or you need to use a scope that can cope with, say, 500 volt input. Mine can't. Yeah, mine's got 300 RMS. It possibly could cope actually, but I'm not going to risk it. So I've got a 20:1 attenuator, Handtech one. I bought it off of Amazon because they deliver quickly, and it wasn't very expensive. I think I bought 2 for £15 or £16. So yeah, it's not going to break the bank and well worth the investment. Okay, so what else have we got here? So I've programmed my scope to recognise the fact that I'm using a 20:1 attenuator. I've got it set to 40 volts per division, per major division. And what's my time base? 10 microseconds on the time base. So each one of these major divisions horizontally is 10 microseconds in time. Okay, so I have run the car already, so full disclosure, so it has been warmed up a bit, although it has been stopped for a bit, so we'll have to see how it runs once it gets going. But let's see if we can get a signal out of this. Okay, so it's running on single. Let's change it to normal triggering. Okay, there we go. So you can see the trigger level is set to around that point there. That will trigger fine anywhere to get it on the rising slope. I think it's set to rising slope trigger. Let's have a look. I'd have to go into the trigger menu and I can't remember how to do it. Here we go. Yeah, rising slope. So it's triggering on channel 1, rising scope on the edge, so it's on that edge it's triggering. That's why that's in the center of the display. You're getting some variation because obviously, you know, the engine speed varies anyway, and we're going to get a bit of variation. Over here, if you notice, if you can just about see it, it says maximum 344 volts. So please don't put your hands on this when it's running, because it's going to give you a hell of a shock. So make sure you use the attenuator, keep your hands well away. All right, I think that's good enough. Let me stop this and it should capture the waveform anyway. Right, now what else can I tell you about this waveform? The collapse, this edge here, is where the spark will actually occur. And this up and down, this is ringing. It's just residual oscillation in the coil, where it drops, creates another magnetic field because it's dropped, because it's induced a voltage in the primary. Then that fades away and it drops again, and you get this oscillation as it gradually fades away. Sort of damped oscillation, if you like. Right, so while I've been doing this, I've discovered something I really didn't know about this car. So here we see a standard sort of primary waveform. Now let me reduce the time base. Now this is the weird effect that I didn't expect to see. So I'm seeing 5 firing events and then nothing. But if I reduce this still further, then let's move this across. And a bit further still. Okay, so we see the pattern repeat. Now the time difference between here and here, I'm on a 20 millisecond time base here, so it's 20, 40, 60, 80, 100, 120, 140, about 145. And if you do the calculation, 145 times 2, because we have 2 cycles per fire, you know, per firing event, and then multiply it by 60. I'll do the calculation on the video. Anyway, the bottom line is that represents 130 RPM, which is about the tick over speed of my car, the idle speed of my car, which means that for every time we want the spark plug to fire, what we actually do is introduce 5 consecutive firing pulses. And just get this to come back onto the scope. Actually, let's do it like this. There you go. You send 1, 2, 3, 4, 5 pulses. You effectively try and generate 5 sparks, I'm assuming, and then that's it for that firing event. And then we go round and we do it again. Now, of course, the concern here is the problem we've got the fact that we've got an issue with this coil or this spark plug or whatever. So let me switch in another channel, and this is just on another one of the spark plug leads. Let's reduce this down, and you can see exactly the same pattern, obviously at different times because this is a different spark plug, but that seems to be how this works. Now what I'm going to do is I'm going to try and rev it and see if we get any change in the pattern. So we clearly saw as the engine speed increased, the number of spark events or spikes in the trace reduced eventually down to 1. Now I managed to find some BMW documentation that in fact confirms that this model of car has multi-spark ignition, and it's used at low engine speeds and or cold engine conditions to improve the combustion efficiency. It says as a guide, I think it said that the multi-sparks only happen below 2000 RPM. So for us in 116 trophy cars, as we spend most of our time at 3,500 upwards, it's not really going to bother us one way or the other. But you do need to have these waveforms, obviously, to show that you have normal operation. All I would say is that depending on the temperature of the car, you may not see 5 spikes, you may not see 4 spikes. I don't know what you're going to see at different temperatures, but you will see, you're quite likely to see multiple spikes when the car is idling. Okay, so that was initially very confusing, but I hope that's clarified everything for you. You'll find a lot more related information on my website, and I'll drop a link to that down in the description for this video. All right, I'll catch you on the next one.